In this video, we're going to talk about correlation, and then we're going to look at how to calculate it by hand. So, a little bit about correlation is it is the measure of the direction and strength of the linear association between quantitative variables. So in this first graph we have here, we have a positive association. So as your x values are getting larger, your y values are also getting larger. And when you have positive association, your R value will be in between 0 and 1. So your R value will be positive. When we have negative association, you can see as our x values get larger, our y values get smaller. And in this case, our R value is going to be between -1 and 0. So it's going to be negative. So that just tells us whether we're positively associated or negatively associated. Now when it comes to strength of association, then we have to see how close our best fit line would be to the values. And here we can see that this is a pretty linear set of dots that I have on this scatter plot, so we have a strong association. And the closer you are to 1 or -1, the stronger your association. In the second scatter plot, I have a mildly strong association. You can see that a line could be drawn down through the middle, and everything is pretty close, would be pretty close to that linear line. And then the last example I have, there's no linear association. We just have a lot of dots and a scatter plot, and there's really no direction or strength to it. So now let's take a look at an example of how to calculate R by hand. And the formula for calculating R is equal to 1 over n minus 1 times the summation of xi minus x bar divided by sx times yi minus y bar divided by sy. So in our example problem, we have coffee is a leading export from several developing countries. When coffee prices are high, farmers often clear forests to plant more coffee trees. Here are 5 years of data on prices paid to coffee growers in Indonesia and the percent of forest area lost in national park that lies in a coffee producing region. So we have the data points 29 and 0.49, 40 and 1.59, 54 and 1.69, 55 and 1.82, and 72 and 3.10. So before we get to calculating R, we need to know x bar, sx, y bar, and sy, and I've found these already. So x bar is equal to 50, sx is equal to 16.325, y bar is equal to 1.738, and sy is equal to 0.928. And if you need a reminder on how to find these values, go back and take a look at the videos to calculate mean and standard deviation. So now we're going to find R. So R is equal to 1 over n minus 1, which is 5 minus 1, times, now in our first set of numbers, our first set of data, our x bar is 50 and our xi is 29. So we're going to have 29 minus 50 divided by sx, which is 16.325, times yi, which is 0.49, minus 1.738, which is our y bar, divided by sy, 0.928. And I'm going to do this for each set of data. So plus our xi in our second set of data is 40 minus 50 divided by 16.325 times 1.59 minus 1.738 divided by 0.928. So that's our second set of data. Plus, we're going to have 54 for our xi minus 50 divided by 16.325 17.325 times 1.69 minus 1.738 divided by 0.928 plus our fourth set of data. We have 55 minus 50 divided by 16.325 times 1.82 minus 1.738 divided by 0.928. And then our last set of data, our x bar is still 50, our xi is 72, 72 minus 50 divided by 16.325 times 3.1 minus 1.738 divided by 0.928. And now we need to take the time to crunch all of these numbers. So we'll simplify. So we have r is equal to 1/4 times, if we multiply all of the first two terms together, we end up with 1.7299 plus the second set of data. When we add and subtract and divide and multiply all these together, we get 0.0977. Our third set of data gives us negative 0.0127. Fourth set of data is plus 0.0271. And our last set of data is 1.9779. And now I'm going to add all these terms together. So I have 1/4 times 3.8199, and then r is equal to 0.955. So we have a strong linear association here. 0.955 is close to 1, and it's positive. So here in part B, we could say that we have a strong positive linear association. And that's how we calculate correlation by hand.